Hello, and welcome to part two of the Android RE crash course. I'm Justin, and in this part, we are going to focus on XML views. We're going to reverse an app by basically reversing the XML views within the app itself. XML views are currently the most common method you would see to make an Android app. However, it is falling out of use due to things like Compose, Flutter, etc., which we talked about in the last video. So if you haven't watched that, please do. So uh, our video is going to focus on a sample app. That sample app is named ByScan for GM. It's actually an app that I developed way back in 2015, 2016, I believe. Um, and it uses, for the most part, XML views. So when we talk about XML views, it's an excellent demonstrator app. In terms of permissions, since I own it, I give you permission to reverse it for any sort of education and skill building that you see fit. So don't worry about the legalities. Our objectives for reversing this app are going to be answering questions: how does it work? And what messages is the app sending to the vehicle? so, when you first get an app that you want to reverse, typically the first thing you'd want to do is actually visit like the Play Store listing or how it's downloaded because you can get good top level information before you even reverse the app. For example, if this was malware, which it's not, at least I hope it's not, and the site it's downloaded from was a banking website and it wasn't a legit banking website, well, that's probably means the APK is phishing, right? You can gain a lot of information before you even start reversing. And in fact, that top level information can save so much time. You should always be looking for it. So in this case, it's ByScan. What information can we get from the listing? Well, it says it is a plugin for Torque Pro, which is a minor OBD2 diagnostic tool. And it says that it performs advanced diagnostics. What are those? Well, for the most part, we don't need to worry about that, but it sends a message to the vehicle and that does something. That's what we want to reverse. So to actually begin your APK reversing, you're going to need to get the APK itself. Now, you could probably just Google the APK you want or go to Virus Total or something. But if you want to fetch stuff from Google Play, you're going to have to follow these steps. Step one is install the actual APK to your phone. Once you have that, you can then use ADB to find the package and where the base APK is located. This is a convenient command that would just search by the package name so that you don't get the rest. Once you have that, you would then need to pull the APKs, plural, including splits. We're going to talk about that in just a second. You could just do it like this line by line, or if you want to be fancy, you could uh, write a script to pull them all for you, but you want to repeat that for each APK. And there's also other ways to get the APK, like let me just show one quick. There's apps like APK Extractor, and the way these would work is they would just move all the APKs into SD card where they're easier to grab. But if you're a reverse engineer, you might want to learn how to do it through ADB just because it's more verbose. All right. If you don't want to do all that, I did provide the link to the APKs here. Or if you don't have a device or can't get ADB set up, there's going to be other stuff in these directories if you do look at them, like OAT, which is an optimization thing, and other information. Just worry about the APKs for now. If you proceed as an Android R, you can start learning about what OAT is. So, why are there multiple APKs? Well, APKs are split into what we call splits. Each split will contain some portion of the code or libraries or layouts that you need to run the application. The main APK is known as the base APK, which is going to contain usually all of the actual Java source codes. Then there would be other splits for, again, device architecture. So if you have like a ELF file for ARM64 and x86, there will be different splits for those configurations. Things like display density. So in this case, we see XX high DPI. You're not going to get the other DPI layouts within that split. It's a storage optimization thing, means that you can download less, spend less bandwidth downloading stuff, be more storage optimization on device, and of course, just also you're also able to um, have like language configurations and stuff. So one caveat is Google Play is only going to give you the APKs needed for your device and configuration. So in this case, I was an XX high DPI device because it was a Pixel Pro, and I had English, and I don't know why I added Espanol to Paso. I have that keyboard selected as a second language. But there you go. It did not give me something like Chinese. It didn't give me Japanese. It didn't give me low DPI or other DPI configurations. It didn't give me any architectures, but that's because this app doesn't have any native libraries. Um, we only got what's here. So that might limit our visibility into what we can reverse. So you may have to install the APK using different configurations to get a good profile, just in case maybe the malware or whatever you're trying to reversing only shows up in one of these splits. But for the most part, you just need to reverse the basic APK. To install multiple APKs on your device, you can follow this handy trick here where you do ADB install dash multiple path APKs star. Very simple. If you don't do that, then more than likely the app will actually crash because it needs all the APKs. How are splits created? Well, splits are usually not created by the developers. They could be, but that's again usually not the case. Instead, when you build what we call an Android app bundle or AAB, it's basically going to contain all the assets you need for your application. So the classes, assets, layouts, blah, blah, blah. Those get signed by the dev certificate, packed into the AAB, and then uploaded to the Play console. The Google Play would then actually, on their end, sign or rather, pack together each of the bait or splits using their own cert. It's possible it might also be an older cert, but for the most part, you'll see it like this, which is actually a Google cert. So don't get confused by that. Just because the cert says it's Google doesn't mean it's actually like an official Google app. It's just this AEB split signing. Boop. And of course, then those would be downloaded on your device through Play. All right. Again, you can just reverse the base APK. That's going to contain all the Java base code almost always. You can just drag that into JDEX. JDEX does support viewing split APKs, but it can be a little weird. So for the most part, I don't recommend doing it unless you have to. With that, we've spent some time talking about splits. Now let's actually talk about XML views. So once again, XML views, just to recap, are the original Android view system. It's actually built into the code that's forked from the Xi code. If you remember us talking about that last time, this is where that is. It's intrinsically XML based. So basically, the way it works is you would inflate a view from an XML resource. That's not required. You can bypass the need to use XML and just make the views and the layout parameters yourself. Having said that, you will rarely see that. It is a malware technique, but a rare one. If you want to get some documentation on all the different types of views and view groups, and please refer to these docs. But at a top level, it's pretty self-explanatory. Just remember it's a mix of XML and Java. When we talk about XML views, you will need to know what the common components are. So something like a linear layout is what's known as a view group, multiple views to put in together. The linear layout is useful for things like lists. Maybe you have like a list of buttons or other elements, blah, 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 is what the linear layout does. Recycler view is different from the linear layout. The recycler view is still, a list, except it's based on an adapter pattern that will optimally reuse the same view for your list items. And in doing so, you don't have to keep everything drawing on the screen. Um, and if you try to like have a list of 1,000 items and you put that in a linear layout, there's a good chance that the device would run out of memory or have an app not responding error or something like that. So recycler views work around that. Oops, recycler views work around that. In Compose, there's a smarter system for doing this. So the recycler view is not as required, but even Compose has a recycler view like system. View binding is a way of mapping the XML view IDs to something you see in code. It's mostly just a convenience thing, makes things a little bit cleaner. There's various mechanisms for doing stuff like this, but the most common one is this one. Constraint layouts is just a common layout pattern you might see. It's based on any constraints to view to handle things like how close should it be to this. Fragments are basically a UI subcomponent that has its own life cycle. It's very useful for what we call single activity lifecycle. So you'll see those being swapped out typically in application that has multiple pages, at least these older ones before things like navigation components and other view-based architectures came along. All right. With that, let's actually begin reversing. So assuming you got the APKs installed and you drag them into JDEX, boop, you should get something like this. So this is the ByScan app. Just take a quick look at this. Obviously, we always want to go to the manifest first. It's good at describing things. We see it query some things. So what this is it's determines which visibility that this app has. It's an alternative to something like query all packages. So if you do something like get packages through the package manager, the guarantees that these would be there. There's also other things there as well. We see it has a foreground service, which is basically a service that runs in the foreground. Usually these days it needs a notification to run. So if you have like a music app like Spotify or something, and you see in your notification bar that it's Spotify, that's typically going to be a foreground service. All right, then we get to actual application declaration. Nothing cool here. We see a receiver called plugin update. Looks like that's doing something with torque. We see the main activity called plugin activity. Boop, boop, boop. Nothing too interesting. Nothing interesting down here besides these services. We see one called plugin update service and one called bidirectional service. Bidirectional service looks interesting. Maybe we'll look at that soon. So we could go look at the main activity quick. Whoop, that's not the main activity. This is. Um, but first glance, I don't see anything too important to dive into. So let's actually run the app quick. So I have screen copy up here. Sorry, screen is black. I have to put my fingerprint in. So this is the app. Now, when you start reversing apps and you know it's going to be like in Compose or XML views, I want you to start thinking about what is this? What is this? It's a dialogue. Okay. Push OK. What is this? It's probably a fragment. Um, the reason I say it's fragment is because there's like this entire thing over here. Boop, boop. And what are these? This is buttons. This is probably made using linear layouts. So let's go ahead and accept this. Again, probably another linear layout. Doop, boop. Has lots of fancy buttons, some sort of PID viewer. Although I did make this app, it was many years ago. It has a manual apparently, which is kind of cool. Tells you how to do it. This is just the privacy stuff again. And a cell to Gratio. So based on this, we probably want to reverse what's in this page. So remember our objectives was to determine what the application was doing and what message it's saying to the vehicle. So probably doing whatever this is going to send that message. So that's what we need to reverse. The question kind of remains, how do we get here? How do we get this code? Because we go back to JDEX, I don't see this code here. And if I do a quick search, if I can find that menu that I just pulled up, let's search for service regeneration. Oops, my bad. Hang on. Service regeneration. So this is actually a dialogue. It's not the actual UI element. Oops, sorry. This is actually a dialogue, not the actual UI element. That's kind of annoying. Well, let's see what else we can find. In assets, there's this wacky thing. What is this? Don't know, but it's encrypted, which means it must be important. So let's see if we can find what this does. Let's search EPIDs. Open EPIDs.xml. It's opening it, uh, doing something. This looks like, oops, sorry. Opening the EPIDs.xml, turning into bytes. And then this looks awfully like decryption. Oh, actually, this looks like it's okay. Here's decryption, and here's the password. So we can tell that the password is the SHA-1 digest of whatever that string was passed in, or rather the first 16 bytes of it. And the file is passed into that decrypted using AES cipher blockchaining PACS5 padding. We don't have to worry about the padding now. So let's just go into CyberChef quick and that's, oh, we may have to find an alternative to CyberChef. There it is. I think I was going to the wrong page. My bad. All right. So let's download that file. I did that ahead of time just so I didn't have to do the ADB pull trick again, or rather unzip it. So let me just find that quick. To pull it into CyberChef, you can simply drag the file right in, and that works fine, just like this. It's not encoded as base64 or anything, so we can just go right into AES decrypt. But we need to get the password, so I'm actually going to make a new CyberChef. Oh my gosh, not that CyberChef. The GitHub one. Go here, take our SHA-1, boop, boop, boop. Don't care about that, but we want that password, which we had in JADEX as this string. For rounds, you want to keep this at 80 when doing a SHA-1. The reason for is things like Java, when you use SHA-1, make the digest of it, it's actually going to do the default number of rounds, which I believe is 80. At least it better be 80 because that's what I'm looking at here. Our next step was we wanted to take 16 bytes, so let's do that. And this is our result. So this should be our key. Let's go back here. EX, change that to UTF-8, I believe. For this, we didn't see an IV being provided, so it's probably just going to be null. So 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. Null can just be zeros. Just like that. And we didn't quite get it. That might be because when you change this to hex. Boop, boop. 80 rounds. Maybe make this from hex to hex. Sorry. That might be our key. There we go. Sorry. Decided to do a little tweaking. So what do we see here? Well, we're looking for the region function. What this appears to be some sort of definition for PIDs, which is like data of the vehicle, but does not actually have information about the controls themselves. Interesting that the developer chose XML for this. Nothing here about controls. That's unfortunate. We're gonna have to dig a little bit deeper. So back to JADEX. Let's look at what's going on here. We didn't find the underlying UI to that service region button, but we do know that has to have a whoops, it has to have a layout. And when it's in that, we go to layout and search for something such as activity main. We see nothing here about service regions. So this is likely the layout being inflated in the actual main activity. You go down here to on create, all right, layout main activity, boop, which is going to be this number here. One pro tip, if this doesn't tell you what it is for whatever reason, you can actually find these in uh, values public, or maybe this one's not doing it that way. All right, maybe not this one, but there'd be a file here called public XML. Anyway, oh, here it is. My bad. Activity main. Cool. Awesome. That's how it gets those numbers. So, what does activity main do? Well, not a whole lot. It has the navigation view, which is that sliding thing we saw on the left, and then it has whatever this is. Uh, Nothing quite useful. So we need to find exactly what is causing this to have UI. What is that? Well, it's probably going to be a fragment. So we need to see, here we go, support fragment manager that begin transaction. The way these work is to change out a fragment, you have to do a transaction. The one we're looking for is known as bidirectional control. There's likely an entire case statement. Yeah, here it is for dealing with these, but we just stumbled across it. So let's just use this one. Something called the r.id mainframe. That's probably in one of these layouts over here. Doop-a-doo. Layout. Let me find. It's possible I had different layouts for. Activity main. Drawer layout, nav view. Ah, here it is, content main. It's in the app bar main. The developer named it app bar main for some reason to confuse us. So basically how the transaction works is it's going to uh, replace this basically. Make sense? Cool. So that's like where the actual fragment goes. Let's get back to that main activity. Where is it? There it is. I'm going to close these other ones just for convenience. So what this is here is likely the fragment. And we can see extends fragment, or likely this was a support fragment manager or or Android fragment. I forget the name of it, but it's been minified to just fragment. So let's see where that button could be. Unfortunately, I don't see anything here about the button, but we do see a layout inflator. What do we know about layout inflators? Well, they inflate XML layouts, and we can actually see it right here in the public.xml fragment bidirectional. So let's actually find that layout in this giant list on the left. Here it is. But this isn't really one we want either. There's no controls or anything like that here. In fact, we see something called the control frame. So probably we need yet another fragment. You can have nested fragments, a fragment within the fragment. So we need to find where control frame is. Where is control frame? Control frame is being set here to whatever cvar1 happens to be. And cvar1 is this thing. And lots of buttons. Oh, we might be close. Oh, this we are very close. Very close indeed. I want to see what layout this is inflating. So let's search for inflate. It's not inflating anything. Oh, there it is. It's fragment group A. Where's fragment group A? Fragment group A is here. It's a big XML layout. So let's try not to get lost here. Let me just resize this a little bit. There we go. So we're looking for the service regeneration function, which is this button here. Buttons work like buttons. So we would want to find something that is listening to this button. And it could be defined here in the actual XML layout, but this time it's not. So we're going to look for this in code. And probably we can find it right in here. Here, so we see linear layout that find view by ID. So the way this works is you can take a view group, which is what we just inflated basically, and then find a view by the ID, which is what this is. It's app plus ID DBT service region, which is that thing in the public. JDX doesn't lead us there if we click it, but it's there. um, then based on that, you can cast it to wherever it is. In this case, it's a button. So we see it's being cast as a button, and you can set the on-click listener. So that's what this is: set on-click listener, new view on-click listener, and we click it, whatever this is going to happen. And that's that dialogue that we saw earlier. So we probably could just look at dialogue, but we wanted to see XML views. So what does this do? Well, there's something happening when you push start. So we probably want to go to that. Oops, sorry. I think I just lost my track here. Hang on. It's very easy to accidentally click the wrong thing in JDX. Okay. Yeah, we want to go here. Looks like we have that warning we saw, which is just hardline in here because the developer didn't want to put in the strings of XML. Yet another function. Yeah, another function. And here it is. This is what we're looking for. So the app is sending A24C0 and a bunch of zeros to the vehicle. I'm not going to reverse exactly how that works. But just to explain it to you, AE is a mode for CAN UDS called device control, I believe. 2.4 is the can't remember at the top of my head, but then the rest of this is basically just parameters that you pass in. That gets sent over CAN to the vehicle. As for what address that is, it seems like it's 70. 70 for 11-bit CAN, I think it is. It's like typically the ECM 70, 71, blah, 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 are the EPA registered modules, as we call them. So our findings here is basically it's sending, let me go back, this message to 7E0, and whatever that does starts a service region. There you go. That's the secret. um, there is, of course, some other stuff that we'd have to look into to replicate this if we wanted to, but that's the secret. All right. So how do we determine what the app does? Well, let's go back to slides. That's not the slides. Our questions we wanted to answer was how does it work? Well, it works by having a bunch of fragments, and depending on which button you press in those fragments, it's going to send a message. And what message is that? Well, it was the AE blah 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 message sent to 7E0. We have fulfilled our objectives. Feel free to reverse the app further. For example, there was that service thing that was the EPIDs that reverse. We haven't really looked into how those work. Lots and lots of stuff to learn within this app, but hopefully what we saw here was how we can use the XML views, look for things like buttons and set on click listeners to quickly and effectively reverse the application. That's all for this video. Thanks for watching. Next video, we'll look into dynamic analysis of things like Perp Suite, so stay tuned.